Hey, thanks for tuning in, IGN. I'm gonna explain you my approach to the challenge problem you guys gave me, and yeah, I just would like to tell you my thought process. Starting off, I want to tell you how I understood the problem. I email Adam and make sure that the extra piece contributes to the value because I was a little confused. I was a little confused if it could still contribute to the armor value and like the armor value in total because I was like, can you really wear another piece of like say if you have two pair of boots, like would that really happen? But it turns out it does. So I'm explaining you my approach if I included that. And the way I understood the problem is was I'm getting a certain number of crowns currency, and I'm trying to maximize my value out of those certain crowns. And the data set you guys gave me, I understood that between the cost and the value was really arbitrary. There's no correlation, or between them they were just really picked at random. So I really couldn't find a strong correlation between the cost and value, but I still could use it some way. I'll show you later in my approach. But starting off, I came up with two approaches to the problem. The first one is kind of like the simplistic way. I was really confident in it. You build a table of the highest armor values as possible, and then you're gonna kind of curate the table to see can you afford this or not. And I have an example down here, and I'll just go through that later. And I added a kind of a VC approach to a VC ratio, and I'm not comparing like the kind of like not the least to greatest in dollars, but I'm comparing would it be the best value of kind of for me to buy. You'll see what I mean when I explain that later. And before I kind of go through my example of this, I want to explain that I came up with a second approach as well to use dynamic programming. With that, I saw that dynamic programming could be used in this problem in a sense because it reminds me of the knapsack problem, where you have your certain weights and your certain costs, and you're trying to maximize the things you put in your bag or your armor set to get the maximized value for I guess the not necessarily the least amount of cost, but can you afford it? And that was a little bit of beyond my technical expertise, but I thought that was really cool if I could implement that sooner or later. But I want to go with the approach I'm most comfortable with, even though I'm losing more in time complexity and in memory management. I want to go with number one because I know for sure that will work. And so I wrote a little example here for myself. I have my chest, my legs, my boots, and my helmet, and an extra set here. And I understood that each of these contributes to one armor set, and they each have a cost value, and I have a little extra variable called value to cost, which I stored in floats in the program. And down here, I was like, okay, since I'm trying to build a table of the highest armor values as possible, let me just take a greedy approach and only look at the values here and choose what I think the highest value out of each set of armor. And the first one I have is C3, F3, B1, H3, and for my extra piece of armor here, C3 because it's the highest of the high, and my cost would be 35 and my value would be 42. And I ask, can I buy it? I say no, according to my arbitrary, arbitrary currency over here, which is 30. And so next, I want to see the next highest possible value of armor to see if I buy it again. And to do that, I want to look at the least amount of change in my value, but kind of not necessarily consider the highest amount of change in my cost, but I want to look at the least amount of change in my value to get the highest possible armor I can buy. Also, I guess I'm making the table, so I'm curious. I asked about this later. So the next highest value I can find is I look at the second highest type of armor in each set, and then once I do that, I figure that the overall total to have a difference of one, the minimal difference, I have to change my chest 3 to chest 1, or I can change my H3 to H2, and the difference will only be 1. And so the way I figured to which one would I do is to look at the V's to see the value of cost. And if I look at that, if I choose the highest one, intuitively you want to pick the highest one to have the most value out of your cost, so you have the most bang for your buck. So that's why I ended up going with C3 to C1 and instead of H3 to H2. And I'm explaining that because you'll see throughout my code, that's how I have my algorithm implemented. And you run through some test cases where it kind of gets hairy, but for the most part, it should work. And so once I do that, I change my C3 to C1. That's the only thing I changed because I want just the minimal difference to be, 1. And I have my same loadout with a currency of 31, and I can't quite afford it yet. So I still say no, and I kind of repeat the process of what I explained earlier to have the smallest difference and to get that 40. And the only thing I changed this time is my extra piece of armor, and the cost is 27. And I say yes, because I can afford that. And so naturally we can enter there. We can buy our highest armor value. But if I really, really want to be greedy and try to buy something with an extra three I guess crowns I have from what I spent, I could go through the table again to find something else I could buy, but that's really not gonna be, I guess, feasible because I guess I have my highest armor value right here. So I think this approach works. I'm confident in it, and you can look at my code and see what I did. And I want to thank you, IGN, for letting me apply to this internship, and best of luck.